What if your home could breathe? What if it could drink in sunlight, clean the air and turn it into energy, just like a tree? That's the idea behind artificial photosynthesis, a scientific breakthrough that could change how we power the world. Hi, I am Fathiah, and today I will take you on a journey that starts with a leaf and ends with a vision for a greener planet. We will look at, first, how this technology works. Second, a major breakthrough by the University of Chicago. Third, its impact on waste and energy. Fourth, why collaborations matters. And fifth, my own innovative idea and the potential of this solution for our future. Let's start with the original master, the leaf. Through photosynthesis, plants take in carbon dioxide, water, and sunlight. With these ingredients, they create glucose for energy and release oxygen. It's a clean, natural, efficient system that's been working for 1 billion of years. What if we could copy this? That's the idea behind artificial photosynthesis, mimicking nature to solve today's energy crisis. Imagine a technology that could do the same thing as a leaf, but instead of making food, it makes full, clean, storable, usable food. That's what scientists are racing to develop. And now they are closer than ever. At the University of Chicago, researchers recently made a huge breakthrough. They developed a system that mimics photosynthesis and is 10 times more efficient than all the attempts. That's not a small upgrade. It's a game changer. Their system converts carbon dioxide and water into useful food using only sunlight. But what made it revolutionary is, first, it used a stable and usable catalyst. Second, it works at room temperature and atmospheric pressure. Third, it can potentially be scaled up. Previous systems were either too slow, too fragile, or too expensive, but this one is showing signs of real-world potential. One of the best things about this system is that it's not just clean, it's circular. Let's break that down. First, it uses carbon dioxide, the gas responsible for global warming. Second, it doesn't produce toxic waste, unlike many chemical processes. Third, it runs on sunlight and water, which are renewable and abundant. So, instead of extracting fossil fuels or generating harmful byproducts, this system takes pollution and turns it into power. It's like taking something bad and flipping it into something good. Here's why artificial photosynthesis is so exciting. It doesn't just create electricity like solar panels. It creates chemical fuels like hydrogen or methane. These fuels can be stored for months, transported through existing systems, and used in vehicles, power plants, or homes. This bypasses one of the biggest problems with solar and wind energy storage. Instead of using giant batteries, we can use full tanks. It's energy that acts like gasoline but comes from thin air and sunlight. This breakthrough wasn't the work of one person. It was the result of deep collaboration. At UChicago, chemists designed the molecular catalyst that start the reactions. Engineers create the framework to keep the process stable. Materials scientists built a structure called a metal organic framework, or MOF. Think of MOFs like tiny sponge with special tunnels where chemical reaction happen. Inside this MOF, the catalyst interacts with carbon dioxide in just the right way. It's like creating a perfect little environment, like a lab in a box. is a reminder modern science isn't just one discipline, it's a teamwork across fields. Let's put this side by side with another tag. First, tag pros and cons. Solar panels, which is clean, renewable, needs batteries. Next, wind turbines, renewable, large scale, inconsistent, location dependent, while carbon capture remove carbon dioxide, often just stores carbon dioxide underground, while artificial photosynthesis use carbon dioxide, creates full, storable, still in early development. Artificial photosynthesis doesn't just solve one problem. It tackles carbon dioxide reduction, clean energy production, and long-term storage all at once. It's not competing with other clean energy. It's completing the puzzle. Here's my idea. Why not install small artificial photosynthesis units on rooftops? Imagine a box about the size of a mini fridge sitting on your roof or balcony. It pulls in sunlight and carbon dioxide and produces hydrogen or synthetic methane. This could provide clean cooking fuel in rural homes, act as a backup power source during blackouts, and reduce household reliance on fossil fuels. It's portable, renewable, and scalable. In cities, it could reduce smoke. In remote areas, it could bring independence, and in developing countries, it could provide energy without building massive infrastructure. So, is this just a dream, or could we actually build this future? Let's stop the challenge. First, for the cost, some materials are expensive. Now, price drop as technology scales, just like with solar. For the durability, these systems need to work in real-world environments, not just labs. Governments and companies need to recognize the potential and invest in it, but none of these challenges are impossible. We have seen renewable tech evolve rapidly before. Just 15 years ago, solar panels were rare. Today, they are on homes, schools, and factories. Artificial photosynthesis could follow the same path. When I first read about this discovery, it really hit me. The solutions to climate change are not out of reach. They are being built right now. What excited me the most wasn't just the science. It was the idea that we don't have to accept pollution and destruction as the price of progress. I want to be part of a future where innovation is a green by default, where chemistry is used to heal the planet, not hurt it. And this project gave me hope that it's possible. So, to sum it all up, artificial photosynthesis could be a cornerstone of sustainable energy. It doesn't just imagine a better world, it builds it molecule by molecule. The University of Chicago's discovery shows what's possible when people come together with a clear goal: clean, affordable, renewable food. It's science with purpose, and I hope today I help you to see the power behind a single idea, powered by light, inspired by nature, and driven by hope. Thank you so much.